Okay, so new topic. We're gonna look at serialization bugs. And to do that, I first want to introduce serialization, because some of you might not know what that is. Well, serialization is the process of translating data structures and object states into a format that can be stored or transferred over the network, for example. Almost all programming languages offer a out-of-the-box serialization format and functionality, so you can just, if you have an object, save the object state, send it somewhere, and then, or save it and then later reconstruct it. So I'm going to give an example of how this works in Python. Well, in Python you have the pickle module, Gewürzgurke. Here I create a class. The class has an attribute name and a method greet. So the method greet uses this attribute to offer some functionality. So I make a new object out of this class. I set the name attribute to Leo. Then I open a file. And then I use the pickle, the serialization tool of Python, to write this object to the file. Here you can see the hex dump of this file. Python uses a binary format, but with some experience you see that there's some ASCII values in here. Here's a new line, for example. There's 61. So what's important here is that serialization only stores the data of an object, not the code. So this function greet will never be saved. The only thing that will be saved here is the attributes, in this case the name, which is set to Leo. So if later on I want to get the object state back, I open this file where I stored my object. I use pickle.load to deserialize the content of the file. And important to note here is that the class that is used in this serialized file has to be present when the object is deserialized, because, as I said, in the file itself there is no code stored, there is no function stored, no contents of a class, no type definitions. It's only the attributes. So in this serialization format it will essentially say, okay, the class is greeter, but not gonna specify what that is or what type that is, and then the attributes. So when I deserialize with load, the class has to be present, and then it works. It just deserializes. Here I'm printing the type of the object, and then I use the function greet on the object, which is this function here. So the output of this would be the type is greeter, and the correct function is called greet hello, because in this scope here the type greeter is this class. Okay, so I want to give you a brief introduction on how serialization exploits on a fundamental level work. So imagine you're writing a server that transfers data over the network in Python, and the server has libraries loaded, obviously, and somewhere in a library there's a user class that you want to use in your application that is transmitted over the network, and this user class has a function called exe for execute the login. Let's say that uses the username of the transmitted serialized object and then does does a login. So this is obviously harmless. We could use this in serialization. But now imagine somewhere else in the loaded libraries, we don't know where, but somewhere, is another class called dangerous. And it has an attribute command, and it also has a function called exe. just like the user object. So now what would happen is, if an attacker submits not a user object, and then the application code on the server side does socket read, it reads the object from the network, and then on the object it calls the exe function. Because the application developer expects here that there will be a user object, and the execute login function will be called. But as an attacker, what happens if we just send a dangerous object with the command set to rm-rf/? Well, then here the dangerous class will be used and the system will be executed, because we use the code flow that the developer wrote, and just by changing classes and attributes we make the code do something we want it to do. So an obvious exploit here would be set the class to dangerous, set the command to something evil, then send the serialized dangerous object to the server, and the server will then call the exe object, but on the dangerous class, not on the user class. Using this, exploiting this only by changing attributes and names without actually changing the code flow is sometimes called property-oriented programming, or POP for short. It's a slight derivation of the ROP, which you will be using in the binary exploitation part. And yeah, this is a very straightforward example in Python. We'll see in Python it's actually easier to use this kind of exploit, but in other languages such as Java that are typed, it's a bit more complicated, but we'll see how you can still exploit this in, for example, Java in the next videos.